At the end of this video, you should be able to distinguish between a mixture and a pure substance. Chapter 1, Section 2, Classification of Matter. The variety of forms in which matter exists is enormous. However, all matter can be classified into one of two groups: pure substances and mixtures. A pure substance can be an element or compound. The composition of a pure substance is the same throughout and does not vary from sample to sample. Mixtures, in contrast, contain more than one substance. They can vary in composition and properties from sample to sample, and sometimes from one part of a sample to another part of the same sample. All matter, whether it is a pure substance or a mixture, can be classified in terms of uniformity of composition and properties of a given sample. Figure 1-8 on page 15 of your text, or on the screen now, illustrates the overall classification of matter into elements, compounds, and mixtures. Mixtures. You deal with mixtures every day. Nearly every object around you, including most things you eat and drink, and even the air you breathe, is a mixture. A mixture is a blend of two or more kinds of matter, each of which retains its own identity and properties. The parts or components of a mixture are simply mixed together physically and can usually be separated. As a result, the properties of a mixture are a combination of the properties of its components. Because mixtures can contain various amounts of different substances, a mixture's composition must be specified. This is often done in terms of percentage by mass or by volume. For example, a mixture might be 5% sodium chloride and 95% water by mass. Some mixtures are uniform in composition. That is, they are said to be homogeneous. They have the same proportion of components throughout. Homogeneous mixtures are also called solutions. A salt water solution is an example of such a mixture. Other mixtures are not uniform throughout. That is, they are heterogeneous. For example, in a mixture of clay and water, the heavier clay particles concentrate near the bottom of the container. Some mixtures can be separated by filtration or vaporized to separate the different components. Filtration can be used to separate a mixture of solid barium chromate from the other substances, as is shown in the beaker in figure 1-9a on page 16 of your text or on the screen now. The yellow barium compound is trapped by the filter paper, but the solution passes through. If the solid in the liquid-solid mixture settles to the bottom of the container, the liquid can be carefully poured off or decanted. A centrifuge, which is shown in figure 1-9b, can be used to separate some solid-liquid mixtures, such as those in blood. Another technique, called paper chromatography, can be used to separate mixtures of dyes or pigments because the different substances will move at different rates on the paper, as seen in figure 1-9c. Pure substances. In contrast to a mixture, a pure substance is homogeneous as a single entity. A pure substance has a fixed composition and differs from a mixture in the following ways. 1. Every sample of a given pure substance has exactly the same characteristic properties. All samples of a pure substance have the same characteristic physical and chemical properties. These properties are so specific that they can be used to identify the substance. In contrast, the properties of a mixture depend on the relative amounts of the mixture's components. And 2. Every sample of a given pure substance has exactly the same composition. Unlike mixtures, all samples of a pure substance have the same makeup. For example, pure water is always 11.2% hydrogen and 88.8% oxygen by mass. Pure substances are either compounds or elements. A compound can be decomposed or broken down into two or more simpler compounds or elements by a chemical change. Water is a compound made of hydrogen and oxygen chemically bonded to form a single substance. Water can be broken down into hydrogen and oxygen through a chemical reaction called electrolysis, as is shown in figure 1-10A on page 17 of your text or on the screen now. Sucrose is made of carbon, hydrogen, and oxygen. Sucrose breaks down to form the other substances shown in figure 1-10B. Under intense heating, sucrose breaks down to produce carbon and water. Laboratory chemicals and purity. The chemicals in laboratories are generally treated as if they are pure. However, all chemicals have some impurities. Chemical grades of purity are listed in table 1-11 on page 8, or sorry, table 1-1 on page 18 of your text or on the screen now. The purity ranking of the grades can vary when agencies differ in their standards. For some chemicals, the USP grade may specify higher purity than the CP grade. For other chemicals, the opposite may be true. However, the primary standard reagent grade is always purer than the technical grade for the same chemical. Chemists need to be aware of the kinds of impurities in a reagent because these impurities can affect the results of a reaction. For example, the chemical label shown in figure 1-11 on page 18 of your text or on the screen now shows the impurities for that grade. The chemical manufacturer must ensure that the standards set for that reagent by the American Chemical Society are met. At this point, you should be able to distinguish between a mixture and a pure substance.